So let's do number 4 here. It says a European car manufacturers reports that the fuel efficiency of the new microcar is 28.5 kilometers per liter, and on the highway, and 22 kilometers per liter on the city. Why are there 2 different ratings? Why is there one for highway and why is there one for city, and why would they be different? Why would the car behave differently on the highway and then on the city? Did anybody have an idea why that's happening? Speed limit, okay. So is it the faster you go, the better fuel economy you'll have?
No. It's because
yes.
in the city you stop and you go, and then in the highway, yeah, you stop less frequently.
That's true. Yeah, so because you have to stop and go, think about how momentum works. Momentum is when you already get something moving and going. If you kill that momentum, it has to restart itself, right? So you have to rebuild moving that massive vehicle again. And maybe we don't always think of them as massive because they move pretty easily for us, but they are really massive vehicles. And they weigh multiple tons usually. And so that's something that in terms of cost you have to pay to re-move again and stop, re-move again. Some of the ways that we've worked to try and get fuel economies to kind of go up is to allow people to take a right on a red instead of just sitting there and waiting and the engine moving and using a little bit of gas. You can take a right on a red if it's safe. It actually was enacted to try and get more the fuel economy to be better, so we aren't wasting as much gas. It's not as easy to do that with the left because you have to cross opposing traffic, but with the right, you're joining traffic as opposed to crossing opposing traffic. Now, the faster you go doesn't actually equal better fuel economy. At some point, you are speeding too fast that you have to put too much into the acceleration, that you're actually spending too much. I think I want to say that the actual sweet spot is somewhere around 55 miles per hour, where it's usually golden for most vehicles. And over that, it the efficiency drops back down again. So it's like efficiency starts going up with speed, and then some points it starts coming back down. So, and I think highway is rated at 55. So when we go 75, 85 on the highway, we're not really getting better fuel time. We're just getting there a little bit faster at a higher speed, but it doesn't mean better fuel economy. So now look at these ratings: 28.5, 22 kilometers per liter. I mean, we don't think in kilometers per liter. I have no idea if that's a good rating or a bad rating. What do we know these things to be in? What are car ratings, fuel economy in America at?
Miles per hour.
Miles per hour, right? So we need to convert kilometers to miles and liters to gallons to have a decent idea of what these ratings actually are. So let me write these down. We've got 28.5 kilometers per liter on the highway and 22.0 kilometers per liter on the city. And it wants to know the fuel efficiency rates in miles per gallon. All right, let me switch to the other camera. All right, I'll do one. I'll do highway. So I've got 28 kilometers per liter. That's what that means, right? This many kilometers I'll gain in forward movement with 1 liter of gas. I'm going to set up the table that I like to use. You don't have to set it up this way, but I've got two conversions to make. I need to do a conversion where kilometers cancel out to create miles, and where liters cancel out to make gallons. So I set up my units. I don't even have my numbers yet, but I've set it up to where kilometers can cancel out to create miles and liters cancel out to create gallons, so that I can end up with miles per gallon. So now all I need is the numbers to punch into this equation. So we'll have to refer to this chart. We want miles related to kilometers. Under length, 1 kilometer equals 0.621 miles. So 1 kilometer equals 0.621 miles. And then for gallons, 1 liter equals to 0.264 gallons. By the way, if you're doing math off the top of your head, a liter is very close to a quart. So if you're just trying to think things through, it's either a fourth or 4 times, you know. So that makes it a little bit easier to remember, to relate those two. So 1 liter is close to a fourth of a quart, just a little bit over. All right, so you multiply everything on the top and divide by everything on the bottom, and you get our answer. This ends up being 28.5 times 0.621 divided by 0.264. It's 67.03977727. These were given in 1 decimal place, so we should cut it off like that, and it would be 67.0 miles per gallon highway. All right, so I showed you highway, you calculate city with the 22 kilometers per liter. You should get a lesser number than I got. I'll give you a few minutes to solve that problem. Did everybody get their answer? Should have been in the 50s. All right, if gas costs 3.50 per gallon, so that was A, B. If gas cost $3, can't write, $3.50 per gallon. It's a different price now. How much would it cost to drive 500 miles in the city, assuming the fuel efficiency rating is accurate? Sometimes they're not all that accurate. It really just depends. But assuming that it is accurate, with the city value that you calculated, what would be, how much would it cost to go 500 miles? So what steps should I take? 500 miles in the city, what would that look like? fuel economy was 51.75 miles per gallon in city. It's gone 500 miles. Okay, so divide the 500 by the miles per gallon. Okay, let's look at the divide 500 miles, someone said, by the rating, miles per gallon. That would be miles per gallon. That would leave us with gallons. That's good. That's what we want. So 500 divided by 51.75. This would be, so this would end up being one divided by 1 over a gallon. When that happens, well, I won't over explain it right now, but when you have a reciprocal of a reciprocal, you end up having it being the numerator. So it ends up becoming gallons like that. Okay, so now that I have gallons, what do I do with that number? We've used this number and this number. Now I need to use this number. How do I use that number? Yeah, multiply them. Because this is dollars divided by gallons. If I have divided by gallons and multiplied by gallons, gallons will cancel out. It's always a good idea to look at the units. Now, I may have written it down like reduced, but I'm keeping the entire decimal when I multiply, times 3.5, to maintain a little bit more accuracy. When you're doing like, so this one we can round to the end because that's, so when you're doing math, you can round at the end to display the answer, but in the middle of the math, you don't round in the in-between steps. You keep as many decimals as possible to kind of maintain accuracy. Remember, accuracy is about how close you are to the answer. So you keep as many decimal places as you can, and with a calculator, that just means that you constantly use the number that has all the values there. And then you round at the very end to write it down shorter. All right, number 5. In the long jump, if you can jump 5.92 meters, what is your jump length in feet and then in yards? Yeah, a lot of times in world competitions, most things are in the metric scale. So what is 5.92 meters? Something that you could understand. Does 5.92 meters seem like a long distance? How would I convert meters to feet? I feel like doing like Blue's Clues with our handy dandy conversion chart. So 1 meter equals 3.80. Sorry, I can't read. 3.28. So you could do cross multiply and divide here. We want to convert it to feet, and it's 3.28. Whoops, no, 3.28 feet for 1 meter. All right, that gives me 2 equal fractions here. So we cross multiply, so that means you would have multiplied them. 5.92 times 3.28. That's how much it would be in feet. If we want to go to yards, what would I do from yards to feet? It's by 3, right? Do I multiply by 3 or divide by 3?
Sure, you divide.
So divide by 3. And we can round it off there with the 2 decimal points here, so 2 here. Yeah. That would be yards here. That was for A. So B has you doing yards to meters, so going backwards. No, meters to yards. So we just did that. Feet and inches mixed together to make meters. Meters to a mile. And then miles in kilometers. So y'all can do that all without me. These next ones you should be able to run without me. So do B, C, D, and E. Try to do those on your own. Keep the Zoom open, so if you need to check or ask questions, then I can answer them for you.